So welcome back to Semicon West here in Phoenix, Arizona. I'm joined now by Mark Borowicz and Ardy Sidhwa from Pure Wafer. Nice to see you guys. Thanks for coming in.
Thanks for having us.
Okay. So first of all, if I turn to you, Mark, let's talk about the business side. You're in the business of wafer reclamation. And before we went on camera, you gave me this incredible statistic that for every 100,000 wafers, 30 to 35,000 of them end up getting recycled.
Yeah, it's an additional 35,000 that they use in reclaim in the IDM sections for all preventative maintenance on the tools.
Right. And this is essentially tied to the fact that these machines need preventative maintenance at regular intervals, and so therefore they need to get recalibrated or whatever using these test wafers.
Yeah, it's a trust issue. So they don't trust the service person that he did his job correctly. So they'll run thousands of wafers through the tool and then run them through metrology. Yep. That have to present the data back to the IDM engineer.
Right.
And he says, yes, I agree, we can put this tool back into production, or no, start over again. And all of those wafers will come back to us.
Right, okay. So maybe Ardy, you can tell me about the process. Once you get these wafers, what do you do with them? How do you treat them? How do you calibrate them? How do you classify them and send them back?
Absolutely. So once we get the wafers from our customer, we sort them by different films, metals, non-metals. Once the wafers are sorted, they go through our strip and etch process. Mm-hmm. And strip and etch process, we remove those films from the wafer, and then it is sorted again through our automated sorter, where we measure the thickness, type, all of this in different types for wafers. Right. And then after that, we have to polish them. Polishing occurs on the front and back of the wafers, and then there is another type of polish which occurs on the front of the wafer. Mm-hmm. After that, it has to go through what we call precision cleaning step.
Right.
It's a thorough process cleaning of the wafer surface where we make sure that any kind of defects and particulates are removed from the surface.
So this is a chemical cleaning process?
It is a chemical process. After that, we verify those wafers. And we verify those wafers by using metrology tools such as KLA, for example, SP3, SP5, that can go down all the way to 26 nanometers of defect size. Right. And then we make sure that the wafers are cleaned thoroughly. And then we also use another method called ICP-MS to make sure there are no metallic contaminants on the wafer. Okay. Once that is done, we package them according to the customer requirements. Mm-hmm. And then we ship them back to our customers. So we have all the QA setup and all the data that is required by the customer so that they can verify that these wafers are meeting their standards.
Right. And so Mark, these customers, when they get these wafers back, I mean, they can recycle them up to 15 times, is that correct?
10 to 15 times, depending how abusive they were on the wafers. Some steps are more abusive, so it's a little bit hard. You have to remove a little bit more material. But typically 10 to 15 times we can recycle those wafers through.
Right. So it's quite a process, isn't it? So I believe you actually also made an acquisition recently, a company called Adion, is that correct?
We did. So our other product lines that we usually do, we do brokerage. So when we do wafer reclamation and you sent us 10,000 wafers and 9,800 survived and you want 10,000, we'll go and buy wafers, 200 wafers to make sure you get 10,000 back.
Right.
We do a thin films business where you can buy a wafer from us, and if you need a certain film because you have to do some R&D work, customer's not happy with your product or something and you need wafers, we can put all different kinds of films on those wafers and sell you that also. The last part is a company we bought a few years ago called Noel. They make a standards business, and so they make standard wafers for all the metrology, inspection, even a lot of the process equipment companies.
Okay.
We make a standard wafer for them, and they continue to use the standards to make sure that their tools are up after preams and different types of steps.
Right.
And Ardy can talk more about the Noel business itself.
Yeah. Okay.
Absolutely. So not only standards, but our approach is from lab to fab approach, right? So if there are startup companies and they want to develop something new, put certain type of films on certain structured wafers or square, say, ceramic piece or a sapphire, we can help them out with that. So that's another niche market we concentrate on. Another market is also microfluidics on the bioengineering and biochemical side. So Novell versatility is, and this is the only lab to fab approach company in the US that I know can do from 2-inch wafers all the way to 12-inch wafers.
Right. Wow.
And that brings more value for Novell and for Pure Wafer, because not only Pure Wafer can support from the wafer standpoint, but Novell can deliver different type of films and structures on those wafers to our customers.
So I can do 2-inch, 5-inch, 8-inch, 12-inch.
Anything, yeah, all the way to 12-inch.
Right, right. Wow, that's interesting.
Yep.
Yeah. So what's the application they use it for in microfluidics?
It's mainly on the bio side. DNA sequencing is the one area. Pharmaceutical can use that to identify or separate the chemical analysis in the medicine itself.
Okay.
So those, we, instead of calling chips, they are called slides. And these are slides with certain type of structures within the slide itself. And then we design those slides, and then it goes to them. And they utilize by putting their chemistry or their solution into the slide to identify what is good and what is bad in terms of the cells itself.
Excellent, excellent. Well, gentlemen, it sounds like you've got a good business there, and certainly a very necessary one. So I really want to thank you both for coming in and talking to us about it today.
Thank you so much.
Okay.